We're gonna start with 4-6, and this is another one-link robot. This is another one-link robot problem. So we're given L equal to 14.42, and the orientation of it, so theta is equal to 123.7, and it asks us to find the x and y coordinates of the vector and express them in both polar and rectangular form. So let's first draw this. So this vector we'll call P, has a length of 14.42 at an angle of 123.7, right? So if we want to find, this problem's asking us to find the x portion and the y portion of it. So this is pretty much exactly what we did on the previous lab. So x is equal to 14.42 cosine of 123.7. Alright, so this is going to come out to be x equal to minus 8.0 centimeters. Now, if we want to find y is going to be equal to 14.42 times the sine of 123.7. This comes out to be 12.0 centimeters. So we now can represent this vector in rectangular form because we have the x component, we have the y component. So this is equal to minus 8 I hat plus 12 j hat, and this is rectangular form. It also asks us for polar form, right? So for polar form, what do we want to do? We got to find a magnitude and an angle, right? So in order to find this, we do the polar form of this is equal to the magnitude of P at an angle of theta. And we know this because we were given both a phase and a length and an angle already. So we don't even have to do anything with this. This is just equal to 14.42 at an angle of the 123.7 degrees. And that's given straight from the problem. Okay, 4-7 is very similar to 4-6. The only difference is the orientation of the angle, the length. So 4-7. This is another one-link robot problem where the length is 15 centimeters and the angle is equal to negative 120 degrees. So if we were going to draw this, at negative 120 degrees, we're going to go from here 120 degrees, so that we're at theta equal to minus 120 degrees. And the length is 15 centimeters. So the same way we found the x component for the previous problem, the y component, we do the same exact thing. X is found by cosine, right? Y is found by sine. So x is equal to 15 times the cosine of minus 120 degrees. This is equal to minus 7.5. Y is equal to 15 times the sine of negative 120 degrees, which equals minus 13.0 centimeters. So rectangular form of this, P hat, is equal to minus 7.5 I hat minus 13.0 j hat. And the polar form of this is our magnitude and our angle right here. So it's converted 15 at an angle of minus 120 degrees. Any questions on that? Good. I'm pretty sure 411 was one of the pre-recorded videos, so just watch that beforehand. And you had a question with 413?
Yes.
All right. So 4-13. So it's saying a force, it gives us the following drawing, right? It's a wheel, looks like. And it's saying a force is being applied right here of 20, what is it, 20 pounds of force? 20 pounds. And we're at an angle of 45 degrees. So it's asking us to find the horizontal and vertical components of this.
My biggest question was, do we automatically assume in these cases that the 20 pounds is the magnitude?
Yes.
Okay.
So the 20 pounds, yeah, 20 pounds. Because we can think of this as a vector coming down onto this as 20 pounds. The 20 pounds. So now we would do the same thing that we did before. So our x, it asks to find the x and y portion of it. And so 20 pounds negative x is determined. So, but we have to remember that this is in the second quadrant, though, right? So we would have to think of this as the second. So our x value, well, I guess the way that they're saying it is it's actually not in the second. It's going to be in the fourth quadrant. And the reason they're saying that is because they're saying that this is the origin right here. So it comes down here and there. And our 45-degree angle would actually be that angle. So maybe I should redraw this. Yeah, I'll just redraw it for in case anyone goes back and looks at this. So we have 20 pounds of pressure coming down right here, and an angle of 45 degrees. So we can think of this now as a vector at 45 degrees in the fourth quadrant with 20 pounds of pressure. So now F of x, the force of x, is now just equal to 20 times the cosine of 45 degrees for the x. And then this is equal to, and it will be negative 45 for f of y, but this is equal to 14.14 pounds of pressure. Now f of y is equal to negative 20 times the sine of 45 degrees, because really it's a negative 45 degrees, but that just relates a sine, so it would bring the sine outside of the outside of all this, so it would bring it there. So this is equal to negative 14.14 pounds. So we can represent this in rectangular form that the force is 14.14 minus I hat minus 14.14 j hat. Sure, yeah.
20 is the
Okay. And 414 is essentially the same problem. Just plug it in. Yeah, that's right. And then what about PY? Minus. It's a negative. Because it's in the fourth quadrant, because the force is coming down at that angle. So the force will be represented as a vector in the fourth quadrant because it's coming down, right?
So 14 basically py equals 8.6 and what negative and px equals 5.
414. You get negative 8.66 for y.
Negative 8.6 and I got positive 5 for x.
For x, yeah. 5 for x, 8.6 for y. That's right. It's literally the same exact problem. You just have to plug in the different values. So,
Crazy, I'm doing this in my algebra class right now.
really?
Yeah.
Good. Then you're on top of it right now.
Right? I'm so happy. Don't worry, I can get home.
All right, and then the last problem that I'll go over is 416. And this is similar to what we were doing in class today with complex, but we're just doing it as vector form. So we have a triangle. This is what we're given, right? We're saying that this is V, this vector V, and we have an angle, and we're saying VL, which is the inductance, the voltage across the inductance, is 15 volts. And we know this today because the Y portion is the imaginary portion, right? So, and the inductance is, it was imaginary. No, this was a vector problem. So they kind of just are relating vectors, and then the reason why they made this probably the last problem is for the lead-in into complex numbers and complex pro. Essentially it is, yeah.
Essentially, or it is?
It is. I mean, yeah, it is. It is, but you just have to know your coordinate plane is different. You have your imaginary coordinate plane versus your regular XY coordinate plane. And remember that it is complex. So it'll have a real portion and an imaginary portion. But the magnitude and the phase can be found using Pythagorean's theorem. It's just, and your imaginary real parts can be found from it as well, your x and y components of it. So it is all Pythagorean's theorem. So, and we want to find the total voltage here. We want to find V, which we're saying is equal to VR plus VL. And we have this, we can just, and we know from what we did today, if we're doing addition, the easier way is to handle it in rectangular form instead of polar form, right? So we'll handle it as VR is equal to 10 I hat plus 0 j hat, and VL is equal to 0 I hat plus 15 j hat. So if we're going to add this up for V, all we're going to do is add our x components and our y components. So we have V equal to 10 I hat plus 15 j hat. And this is in volts.
If I didn't put volts in that, yeah.
Nah, don't worry about it. And if we want to convert this to polar form, what are we going to do? What do we need? An angle and a phase.
I got an angle of 26, 56.
No. Yeah. Well, let's just go through it. We'll do 10, yeah. So our magnitude is equal to the square root of 10 squared plus 15 squared, which equals 18.03. Then if we want to find the angle is just found through the inverse tangent of 15 over 10. This comes out to be 56.31 degrees. There we go. This is polar.
So theta equals 56.38.
0.31.
I didn't
Yeah.
have 15, I had 5. I don't know how.
Probably just saw it. Those are those little mistakes that always happen, but if your process is right, I don't take. I mean, I don't know. He'll probably have me grade the exams as well, but on the exams, I can't give you full credit if the answer's not right. If it's not right, I can't give you full credit, but if the process was all the way there, and like he said, if he made it a 5 instead of 15, but the process, you're going to get the majority of the points. You're just not going to get full credit on the exam. So that's pretty much.
Is the engineering department as tic-tacky as the math department?
With points, probably. The grading scheme